Welcome back to part 2 this time of our C++ course. Now part 2 is a real step up from part 1. In part 1 we learnt a lot of the basics, but this time, as I say, it's time to do something a little bit more interesting. We're going to look at saving and reading data, extremely important of course for scientific programming. We're going to look at arrays and what they're like in C++. That's something that makes C++ different to C. And finally, we're going to look at functions and mysterious header files. You think you know everything about functions, but wait till you see how C++ deals with header files. I think one of the big goals for this course is that you should be able to look at production code from someone else and be able to understand what each bit does. When we look at forward declarations in header files and when we write some functions, we're going to really get a good look at how this works in C++, and I think it's going to get you to a point where you should be able to understand most code that you come across. So that's all ahead of us. Let's dive in.
Well, before we crack on then, how about we just make sure that we're all ready to go. We have the GitHub page, the repository loaded here, github.com/pecnet/course intro to CPP. This is all the stuff we did last time. And we can now scroll down to part 2. Here it is, arrays, files and functions. I have my terminal window open. I'm in the CPP folder. That's where we saved all of our C++ files last time. We can see exactly what's in that folder by typing ls. ls lists all of the files inside. And these are all of the files that we played with in the first part of this course. And then we can open up Atom as well. And here's Atom, squarenumbers.cpp is open. You can see that's open here. That's the last thing that I played with, but you know, it could be different for you, and that's fine. Again, we have the CPP folder open down here and all of the files that we played with last time. If you have all of this ready, then you're good to go. And specifically, I'm going to set you a challenge. Here is the challenge. It's about the Collatz conjecture. Now let me tell you what the Collatz conjecture is. It's a mathematical conjecture that says if you take a number n, and then if n is even, you halve the number, but if n is odd, then you do 3 times n plus 1. Okay, and then you take that number and you do the same process over and over again. So whatever number you start with, you do this process. If it's even, you halve it. If it's odd, you do 3n plus 1. You then take the output, you stick it back into the same system. Round and round you go. And you can look up the Wikipedia article for the Collatz conjecture. I mean, there's a pretty long article here that tells you all about it, but really all you need to know is the XKCD version of this. So here's an example. If you take a number, for example, 34, well, it's, okay, you can enjoy the joke as well. It's even, so you halve it. And then 17 is odd, so you do, okay, 3 times 17 plus 1, that gives you 52. And you keep on going around this process. 52 is even, so you halve it. 26 is even, so you halve it. 13 is odd, so you do 3n plus 1, it's 40. And if you keep on going, the Collatz conjecture says that you will always end up at 1. So this is an unproven conjecture in mathematics. It looks, I mean, we've done some extremely large numbers, and it looks like this is always true, but it's unproven. So my task to you is to try and get C++ to output the path, Collatz path, that is to say the sequence of numbers that you generate in order to get to 1 for any starting number. So you will be able to ask for a number to be input, and then you're going to take that number and you're going to perform this Collatz function. You're going to halve it. If it's even, you're going to do 3n plus 1 if it's odd, and you're going to keep on doing that until you hit 1. This is a test of if statements from last time, and it's a test of while statements from last time. Let me give you a little bit more, something more to hold on to programmatically. So here we have the Collatz conjecture. I want you to create a new script, Collatz_conjecture.cpp, which inputs a number n And while n does not equal 1, you're going to let f be n over 2 if n is even. All right, so you're going to have to remember how to test whether something is even or not. And if you don't remember how to test whether a number, an integer, is even or not, then you can go ahead and look it up. There's a particular symbol you need to use. And if n isn't even, then we're going to let f be 3n plus 1. I want you to display f, let n equal f, and then you just keep on doing this because it's going to be in a while loop. So that's the plan. I'm going to give you really as much time as you need. I think this might take you 5-10 minutes or so. But have a go. This just hopefully should bring back everything from yesterday's session, and then we'll come back and I'll show you how I did it. Alright, so here's how I programmed the Collatz conjecture. I started by creating a new script. I'm going to head over to Atom, and remember square numbers is what I had before, but it doesn't matter. I'm going to use the guts, however, of this function. So I'm going to copy and paste square numbers of this script rather, and I'm going to create a new file. I'm going to paste it in here. We said we're going to call it Collatz conjecture, conjecture.cpp. Here we are, and it's gone all colourful because it recognises it's a C++ file. Let's get rid of the guts from the inside. Alright, so we're ready to go. The first thing that we had to do was to input an integer n. So we're going to declare that an integer is about to come our way, int n, and then we're going to ask for a number. So we do that by first couting something to the user, input a number, and we'll end the line. And then we will read in the number. So cin reads in the integer n. Okay, so far so good. Now I said while n doesn't equal 1, so that's while n does not equal, so remember that's exclamation mark equals, does not equal 1, then, okay, so our curly brackets. Now we have to test whether n is even or not. Now if n is even, so if n is even, that means n mod 2 equals 0. So let's have a look at what we're going on here. We have used the percent sign to do modular arithmetic. So n%2, n mod 2 will be 0 if n is even, because it's the remainder that you get when you divide n by 2. If it's even, you get 0, and if it's odd, you get 1. So n%2 gives you the remainder when you divide by 2, modular arithmetic. So if n mod 2 is 0, then it's even. Then we're going to let f be n divided by 2. Now at this point we should say we've introduced f. F is also an integer, and so we have to make sure we declare it int f up here. So we're back. So f is n over 2, else, well, f is 3n plus 1, right? F is 3 times n plus 1. So we're going to do this. Note that, of course, f does stay as an integer, even though we're dividing it by 2 here, right? Because we're only dividing it by 2 if f is even, if n is even, rather. All right, so we've done this, and then we let n equal f, as we said, and we're going to output to the screen n. And at the end, we return 0. Okay, so that's my Collatz conjecture. And let's see whether it runs. Let's head over to the terminal. We can clear this. All right, so we're going to compile C++, Collatz conjecture.cpp, and we're going to output it into a file, which I'm also going to call Collatz conjecture. Here we go. Does it compile? Yes, there we are. It made us wait a little bit, but you know that added to the tension, so that's always good. Let's go ahead and run Collatz conjecture then. So here it is. Let's run the file. Input a number. Oh, I don't know. How about 5? All right, here's the path then. So 5 is odd, so we do 3n plus 1, that gives us 16. Great, and then 16 is even, and of course 16 is also a power of 2, so everything as we go down is also going to be divided by 1. How about something a bit more interesting? Let's go back to that. Let's go back to the XKCD and find a more interesting number. I don't know, maybe something like 44? That should be good, right? 44 is a nice long path. Let's ask for 44. Let's do the same thing. Okay, input a number, 44. There's the path, nice and long. Is it in fact the same? Or we can compare, can't we? 44, 22, 11, 34, 17. Yes, okay. XKCD's got it right, and so have we. Good stuff. All right, so hopefully now you're feeling warmed up and ready to learn about some new stuff. So if we head back over to the GitHub repository, we can begin learning our first thing today, which is saving and reading data. If you want to make sure that you have a cup of tea ready, now is a good time to pause. Now, something all good scientific software has to do is to save and to read data files. Of course, you're creating a lot of data, you need to make sure it's saved somewhere sensible. So let's see how we do that in C++. We're on to section 9, saving and reading data. And in order to do that, we need to use the fstream library. Before, when we were streaming to the screen, printing things on the screen, that was the iostream library input-output, but now we're using the fstream library because we're going to stream to files, F for files. All right, and we're going to demonstrate this by creating a text file called greeting.txt, and we're going to place a greeting inside of the text file. That's the plan. Let's go ahead and do it. We're going to call it save-to-file.cpp. Once again, I'm going to steal the skeleton from a previous exercise. So I've copied and pasted. Go to save as, and I'll call it save-to-file.cpp. Good. And I'm going to take the guts out, like that. Now the first thing I said is that we need the fstream library, and so we're going to go ahead here and include the fstream library to be able to stream out to a file. That's the first thing we're going to do. Now I've also included CMath. In this example, we're not going to need the CMath library, but in the exercise that follows, we are. So I'm going to keep in the CMath library just for now, so that we don't end up confusing ourselves in a bit. So let's go ahead and put in the rest of this file. The first thing we're going to do is we're going to declare what is called a output file stream, which we're going to call my file. I'll explain this in just a second. And then with my file, we're going to open up the text file that we want to write to. Now, it doesn't matter whether this text file exists or not. If it doesn't exist, then C++ will create it for you. So in this case, we can go ahead and create greeting.txt as well. But if it just exists, that's fine. So my folder open greeting.txt, and then to my file, we're going to use that double arrow, just like we did when we were outputting things to the screen. We're going to send our greeting, a nice cheerful hello there, like that. And we're going to end the line. And having opened up the file, we then have to close the file. And this is something that you'll be used to if you've done file handling in some other languages. Once you've opened up a file, you want to be able to close it, because while it's open, sometimes your operating system will stop other programs from getting into that file or changing it or even reading it, because your C++ folder, rather your C++ program, has got a grip on that file because you're in the process of writing to it. So here's the idea: we close it. So this is the structure of the file. We declared this output file stream my file, and then we used my file.open to open up the file, and then anything we want to write to this file, we use the my file output file stream. Now, if you're anything like me when it comes to writing software, you will find yourself copying and pasting this structure from the internet every single time that you want to write to a file. But that's okay. That's no problem at all. That's how we do programming. So let's go ahead and compile our file, C++ save to file.cpp, and we're going to output it as save to file. Let's go ahead and run it. Good. So we're about to run the file. Don't press enter just yet, but we're about to save to file. This is going to create greeting.txt, and it's going to write something in there. So let's take a look on the left-hand side at the list of files inside CPP. You will see that greeting.txt is not there, but look what happens when I run a new file, a new program. Here it is. Greeting.txt has arrived. Shall we open it up? Take a look what's inside. Hello there. What a surprise. Lovely. So that's all good. So now I have a task for you. I want you to create a new file, save to file2.cpp, and in it, I want you to get the program to print the first 10 square numbers to a text file called squarenumbers.txt. All right, so that's the exercise. Once you've done that, I actually want you to run the program again. I want you to run the program again and check your text file and see if you can come to some sort of conclusion about what C++ does. And then once you've come to that conclusion, you can read the third bullet point. So there's your task. Time to pause because it's over to you. All right, let's go ahead and create this new file, save to file 2. Okay, so I'm going to use the structure from our previous file, and I'm going to call it save to file 2.cpp. There we are. All right, so once again, I'm going to open the file. We're going to write not to greeting.txt this time, but to squarenumbers.txt. And once we've opened it up, we can create a loop. So for int I equals 0, we're going to go I less than 10, I plus plus, or plus plus I, up to you. And once we're inside the loop, then we're going to output to my file I squared. And we could do I squared in a number of ways. We could do I times I, or we can use the pow function that CMath has for us, pow I2. And we're going to end the line. We don't need hello there anymore. But once we've done that, we can close the file. Notice that we're doing it this way. We're opening the file, then we're doing all of the outputs in the loop, and then we close the file afterwards. We don't open and close the file in the middle of the loop. Best to open it, do everything, and then close it like that. Okay, so let's save this and run this and see what it does. Okay, so we'll do a CPP, and we're going to save to file2.cpp, and we're going to output a save to file 2. Right. It compiles, that's good news. So we can go ahead and run it. Save to file 2. And this is hopefully going to create squarenumbers.txt. So this is squarenumbers.txt doesn't exist yet, even though these two ones are also called square numbers. They're not squarenumbers.txt. So let's see what happens. Squarenumbers.txt, here it is. There we have it, the first 10 square numbers, that is if you're counting from 0. Of course, you could have started from 1 and headed up to 10 if you wanted. That's really no problem. It's up to you, of course. Let's have a quick think about the second part, which I asked you about. What happens if you run the program again? Okay, so let's head back to terminal, and I'll run it one more time. Okay, so it's run it again. Oh, but squarenumbers.txt hasn't changed. And it hasn't changed because C++ overwrites the contents of the file every single time. Now, of course, if you're trying to output some data, this can be extremely bad news. Maybe instead you just want to append to the end of the file. And if you want to append, then you have to use the syntax I've said here. So instead of just using myfile.open and then the name of the file, you have to use myfile.open, the name of the file, comma, This is all one line. It's just my screen that's wrapped it around. Comma, and then iOS underscore base, colon, colon, app to append to the end. And I know what you're thinking, how am I supposed to remember that? And of course, the answer, as always, is that you're not. You look it up on Google every time. There we go, saved file 2.cpp. I've placed in this command to append. So let's head over to try and run this. Of course, we have to compile it first, right? So we compile the file first, and then we run it. Okay, let's go ahead and check square numbers.txt. There they are, one after the other. All right, good stuff. So now let's go ahead and read in from a file instead. That's the next part down here. We're going to take greeting.txt and we're going to read it in and print it out on the screen. This could be good in a scientific context, maybe if you're reading in some parameters from a file, or maybe if you are doing some checkpointing. A common and very good practice in a lot of scientific programming is that you'll have some big file, it's running on the computers, but maybe it runs for, I don't know, an hour or a day or 10 days. And you need to make sure that if the machines stop at any time, which they often do, or maybe there's a time limit on how long you can run your script for, that when your script is ended, you don't lose everything, right? You have some sort of backup that you can then read in from when you start the program again. So reading in, also important. This time we're going to read in greeting.txt. Okay, so let's create a new file. Once again, I'm going to use the skeleton of old file. We're going to call it read from file.cpp. There we go. Okay, so once again, we're making sure that we're including fstream, and I'm going to just empty that. Okay, I'm going to read in from our greeting file, greeting.txt, and when it's being read in, it's going to be interpreted as a string, right? There's text inside this file, and if I want to use strings, I have to make sure that I include the string library like this. Now in this particular case, we aren't going to use the CMath package at all. You can delete that if you want. I'm going to keep it in, no harm doing so. Okay, so last time we declared an output file stream object myfile. Last time we did offstream myfile, but this time we're going to do if stream input file stream myfile. Okay, so make sure we have an I, and we're going to do once again myfile.open greeting.txt, and we're going to do some stuff in the middle, and then we're going to do myfile.close like this. Of course, the question is, what's the stuff in the middle? So we're going to use getLine, and we're going to use while. This is the structure, and again, once again, to be honest, I normally just copy and paste this. So while getLine, and we're going to take my file and read it line by line into C++. That's how it's going to work. So C++ is going to go line by line through your file. Each line in turn, getLine. So we getLine my file, and it's going to put it into a string. We're going to call that string line, and we're going to put some things inside the while function. Of course, we haven't declared line yet, so let's go ahead and do that. So line is going to be a string. So we're going to declare line to be a string. So getLine, line by line, every time you run getLine, it will take my file and it will put one line from my file into the string called line. And the second time you run it, it will know where it last looked, and it will give you the next line. So line by line, it's going to do that, and we're going to get it to see out whatever is now in line to the screen. So this should read the entire file. Okay, I'm feeling good. I think this should work. So let's go ahead and compile it. C++ read from file.cpp, output into read from file. and then let's go ahead and run it read from file. Is it going to work? Well, I'm going to give you a moment to follow what I've just done. Let's see whether it works for you. And now I'm going to have a go myself. All right. Hello there. Brilliant. Excellent news. Okay, so now we can read in from a file as well. All right, that's all I want to show you about reading and writing from files. Obviously very important. The syntax I think is a little bit strange, but in my experience we end up just copying and pasting it from the internet anyway. So the next thing I'm going to show you about is something that's extremely C++, arrays. That's all to come. If you want a little pause, now's the time to take it. Okay, time to look at arrays. Now, arrays are a very C++ thing over straight C. But of course, arrays are functions or features of nearly all modern programming languages. Let's have a look at how they're implemented in C++. An array, of course, is a list of items of objects. This is how they look in C++. Let's start by editing squarenumbers.cpp. That's our square numbers file from here. Here it is. We're going to edit it, and we're going to edit it by, instead of printing out the powers or the squares of 1 to 10 directly to the screen, we're going to store the square numbers in an array called square numbers, and then we're going to go through that array and print out the values in that array to the screen. So slightly long way around, but that's how we're going to do it. Okay, so let's go ahead and edit this. Let's see. So instead of outputting, we can blank that there. Just after we declare n is 10, let's go ahead and declare an array of integers. So square numbers, and it's going to have 10 elements inside the array. So it's going to be 10 elements long. Have a quick look at this this declaration. So square numbers, 10 elements long, and these are going to be 10 integers. Now when you have an array, everything in that array has to be the same type, and the type here is integer. All right, so we're going to loop through 1 to n, 1 to 10, and we're going to say square numbers I, right, because we start at 0 going up to 10, is going to be equal to I squared. So that's pow I comma 2. So having done that, we're now going to get C++ to print out that array. Now you can't just see out an array, unfortunately, in C++. You have to loop through the array and see out each one in turn. We will see in, well, we will see in the third session, the third part, what exactly happens when you start trying to see out the array. You start hitting pointers. But that's all to come for you in the third part of this course. So we're looping through i's 1 to n, and we're going to get it to see out square numbers I, like that. So we loop through 1 to 10, that's n is 10. We're going to loop through 1 to 10, or 0 to 9 I suppose, storing everything in square numbers, and then we're going to print out from square numbers like that. Let's just see that that works. So let's save. Let's, I'm going to clear this. Let's compile. So C++ square numbers.cpp, I'm going to output it into square numbers. All right, so let's go ahead and run it. There we are, square numbers. There they are. Okay, good. So far, so good. So as I said, if you try to see out the array, it doesn't work. But let me show you what happens anyway. So let's try to see out square numbers by itself. All right, so let's compile, run, and you get a memory address. All right, so again, we'll talk in part 3 about what that's all about. So what we've done so far is that we've declared an array square numbers, and then element by element we've entered values into that array. Now that's not the only way that we can declare an array. You can put elements into the array right at the beginning. So let's suppose we have another array which we're going to call favorite numbers. It's also going to be 10 elements long, and we can start by putting some things in it straight away on the declaration line. Now we have to use curly brackets, and we can just list the elements we want in there. Of course, these have to be integers because I've specified it's an integer array up here. So let's have maybe 3, 1, -4, 1, classic choices. Note that we don't have to define them all actually at the top here. Even though we've said something is this array is 10 elements long, we can, if we want to just put 4 in, that's fine, but the array will still be considered to have 10 elements in it. And of course, when you write into this array, you've written these first 4 things in there. When you declared the array, you've specified you want to use this space inside the computer's memory, and you overwrite the first 4 blocks in the memory with 3, 1, -4, and 1. Well, then you've got 6 blocks left. Well, whatever happens to be in the computer memory, whatever used to be in there, is still going to be there from last time. Now, because it might have been zeroed at some point, but it might just still be knocking around there from whatever the computer used that piece of memory for before. And so you've got to be a little bit careful here. But that's okay. So no, we haven't defined them all. We've declared our favorite numbers like this. Let's go ahead and try and print them out. In fact, let's print out all 10 supposedly of these favorite numbers. So see out favorite numbers i.ndl. Okay, how about that? Let's see what happens. This should be interesting. Okay, so let's go ahead and compile as we did before. And now it's time to go ahead and run square numbers. If you haven't been pausing to have a go at these before I show you, have a quick pause and run it yourself, and then we can compare. All right, so let's compare. Let's see. Let's see what we've got. So we've got our square numbers, and then we've got favorite numbers, 1, 2, 3, 4 of them. And in my case, the rest of them are zeros. This memory address is still here because I've still got this line down here at the bottom. So in this case, I made favorite numbers 10 long, and it's put a load of zeros in afterwards. But that is by no sense guaranteed. And the reason I wanted you to have a go first is because maybe you'll get something different to me. Maybe not, but maybe you will. So that's something you have to be a little bit careful about. Some points which I've written down here. So of course you can't see out an array, that's fine. You can only use curly brackets like we did there at initialization time, right? So you can't later say favorite numbers equals and then curly brackets. It doesn't work. Only when you declare the variable for the first time can you use curly brackets. After that, you have to address element by element using this sort of notation. Of course, you can just directly go to it. You can say square numbers 3 equals 100 or whatever. I say you can also declare arrays. You can also declare arrays where it works out the length for you, so long as you give it the entirety of the contents. It can work out that this is 4 units long, and it will make it 4 elements long for you if you just use square brackets like this. I also say that multidimensional arrays work too. So let's actually try this. Let's create magic square like this. So let's suppose here we go, magic square. So this is a 3 by 3 array, right? 3 by 3, and here I've put in the elements, that's the first row, the second row, and the third row. And here, instead of printing out square numbers, let's try and print out magic square, and then maybe the 0th row and the first column. So that should be number 9. Let's have a quick look. So we compile. I fear we've sort of diverged from the original purpose of square numbers.cpp, but that's all right. Let's have a look. There it is, number 9, right down there. So we can address arrays by using sort of separate sets of square brackets. Now, there aren't a lot of functions that you can do directly on arrays. So some basic functionality exists, which I'm not going to show you live, but you can have a go if you want. If you want to try and find the maximum of an element in an array, or sorry, the maximum number within an array, then you can use syntax a little bit like this, where you specify you want the max element from favorite numbers up to favorite numbers plus 10, because it's got length 10. I'm not a particular fan of this sort of syntax. Typically, C++ is a lower level language. If you want to do stuff like finding the maximum or minimum or the average, you have to basically do it yourself. There are packages for more advanced mathematics where you can have vectors and arrays and matrices. Sorry, vectors and matrices, not or sort of arrays that you can add together like you would vectors or matrices. And we'll talk about those as well in the third session. But by and large, you're going to have to do it yourself. All right. Here's my task for you. I want you to create a new file, multiplication-table.cpp, and you're going to print out a 10 by 10 multiplication table. You remember these? I had to memorize these in primary school, right? It's a 10 by 10 times table, and we're going to have, say 10 by 10 array where, you have 1 times 1, 1 times 2, 1 times 3, 1 times 4, and so on. So, go along the top, you get 1, 2, 3, 4, 5, 6, 9, 10. And then the second row is going to be the 2 times table, 2, 4, 6, 8, and so on, all the way down to 10 by 10. So here's what I want you to do. I want you to set up a 10 by 10 array called product. And then I want you to loop through all the rows and columns. Of course, there's 10 of them. So that product row col equals row times col. Right? That's how a multiplication or a times table works. And then I want you to loop through all the rows and columns again, and then print them to the screen using cout. All right, so that's the first thing to have a go at. Now you might want to make sure that you formatting might be an issue for you here, but that's all right. So long as it works, that's okay. Something you might want to try is using end lines, end L, only when you get to the end of a row in the multiplication table, and maybe just using a space between. Or you could use a tab character, which is a \t. So if you use \t, you'll get a tab character, and that might be quite neat for you. So have a go at doing that. And then if you're happy with that, why not try editing readfromfile.cpp? So at the moment, remember, this just reads in greeting. Why not try editing it so that it reads in a list of numbers from numbers.txt, right? So you're going to have to create a text file called numbers.txt, but don't put any more than 10 numbers in there. So here's the idea. You're going to read in the numbers from here, puts them in an array, and then it calculates the mean of those numbers. Right? So there's no nice way to calculate the mean of numbers like there would be in MATLAB or Python. So you're going to have to work it out yourself. This is tricky. This could take you 10, 15 minutes. So if you're ahead of time, great, have a go at this, and I'll show you in length how I've done it. But if you're, if you don't have the time right now and you'd like to maybe look at it later, then you can jump forward onto the next section. But have a go. So let's have a go at doing just this. First, the multiplication table, a 10 by 10 multiplication table. I said we're going to start by making a 10 by 10 array called product. Okay, so I'm going to take this existing file, square numbers, and I'm going to save it as multiplication table .cpp. Okie dokie, let's get rid of this. And okay, so I said we're going to start by setting up a 10 by 10 array called product, right? It's going to be full of integers. So let's say int, we're going to have product. It's going to be 10 by 10, like this. And then loop through all rows and columns so that product row col equals row times col. Okay, so let's have a think about this. So for, and then I'm going to go, now you can choose how to do this, but I'm going to say we're going to go I is naught, I less than 10, and plus plus I. And then we're going to go for j as well. So that int j equals naught. Let's do it the same as that. J less than 10 plus plus j. And then I'm going to say product I j is equal to, and then have a think here. If we do I times j, right, then this is going to give us a multiplication table starting at 0. And if we want to go from 1 to 10, then we have a couple of options. Now, you could go from 1 and then less than or equal to 10, or 1 up to 11, but then we would run into difficulties here. Of course, the indexing of the array has to start at 0. So better, I think, to do it like this. Okay, so we have product ij is I plus 1 up to j plus 1. All right, and then the next thing to do is to loop through all the rows and columns again, counting appropriately the elements of the table. So let's copy and paste this. And now I could just go ahead and do something like this, right? But that would, well, in fact, we can have a look at what that does, right? Multiplication table. So let's C++ multiplication table.cpp. I'm going to output it into multiplication table. There we go. So let's have a look at what that does. Okay, so it prints out the multiplication table, but of course everything is flat. So you've already had to think about this. Here's how I would do it. I would keep the end of lines only once you've got to the end of each row. So we can put an end line here. But then after every element, I would put a tab character. You might have put a space, and that's okay too. But I think it's neat if you use a tab character \t. Let's have a look at what that looks like. So you see \t here and an end line there. So let's compile. Let's run. There we go. That's a little bit neater, right? Good. Now, while we're here, I want to quickly talk about this little node I've put down here. So did you notice up here that I said we're going to let n be 10, but then I didn't put n inside square numbers or within favorite numbers, despite the fact that they're both 10 long. If you try to specify the size of an array using a variable, C++ won't be happy with it, because of course the value of that variable can change, and it's during the compile time that the C++ needs to know how much space it's going to give favorite numbers and square numbers. But of course n can change while you're running the program. So if you want to use a variable to specify the size of your array, you have to tell C++ that it's never going to change. It's a constant. If you do that, then you'll be able to say square numbers n, favorite numbers n. And the way that you do that is by using this const keyword that you put in front of int. So let's go back to Atom, here it is. And let's say const int n equals 10. All right, so now we have that n equals 10, and it's never going to change. In fact, if you try to change it later, C++ will throw a wobbly. So now we can say product is n by n, and we can put n in all these other places down here. Of course, down here it doesn't matter that n changes. The problem was here. If you want to specify the size of an array using a variable, that variable has to be a constant, which is, I suppose, somewhat of a contradiction. But you have to tell C++ it's never going to change with const. Let's just run that just to confirm. Yeah, good. Lovely. The second part of this challenge was a little bit harder, and let me show you how I would have done it anyway. This was set as a bit of a challenge for you. So edit read from file so that it reads in a list of numbers from numbers.txt, puts them in an array, and then calculates the mean of those numbers. So here's how I would do that. So let's first create a list of numbers. I don't know, maybe 3 favorite numbers from that we've had before. Why not? Let's call those numbers.txt. Lovely. And then I said we want to edit read from file like this. So I'm going to save the new version as read from file 2 so we don't overlap. Don't forget, all of these files that I'm creating here, if you ever want to look at them, they're in the GitHub repository. If you go to GitHub and then up to the top in the examples folder, you can find all of the files that we're going to be using over all 3 sessions. So they're all there, and you can have a look at them yourself. Let's go back to where we were. You can always come back and compare. That's the nice thing about this sort of format. Okay, so we're going to read them from numbers.txt and put them into an array. Here's how I would do it. First, let's create numbers.txt. So a new file, bung in our favorite numbers, maybe something like that, 4 of them in this case. Call them numbers.txt. And then here's read from file 2. So you just copied and pasted from the original read from file. We're going to open numbers.txt instead, and you'll see that if you try to run this, actually this will work. Let's have a look at just that. So let's compile it. C++ read from file 2, and we're going to output it to read from file 2. So let's compile. Good. And if we run it, you see that it works, and that's fine. That's the beginning. But actually, you'll see that the next thing we needed to do is to pop them into an array and calculate the mean of those numbers. All right. So here's when the tricky part comes in. We're going to have to read in these numbers. At the moment, we're reading them in as strings, right? We need to read them in as integers. Now, the way that we do that is we have to convert from a string to an integer. So we have the string line, and line has to remain a string. You can't read using getLine into an integer. So we can create int number so that line by line, as we read it in, we can say number equals, and then we're going to convert from a string to an int. And there's a function for that. It's s to I. So that's string to int, right? S to I of line. Now, of course, we could then go ahead and output the number as an integer. Maybe we should just do that just to confirm that it works. So let's compile. Good. So far, so good. The next thing we wanted to do, though, was to put it into an array, right? So let's set up, what should we call it? Array of numbers? Oh, it's a terrible name, isn't it? But anyway, no more than 10. So we can call it array of numbers 10 like that. And then as we read it in, while, okay, so then we can say number equals that, and array of numbers something equals number. But of course, we need to put something in here, the number as we go. But because we're not counting at the moment, so we're going to have to count. So let's create an I. Let's specify that I is an integer. At the beginning, we're going to let I equal 0. And then for every number, we're going to add 1 to I, plus I. So you can think about the logic of what we're doing here. I is 0. Once we've read in a number, we count it. I equals I plus 1. That's what the plus I does. All right, so this looks good. In fact, instead of outputting the number, we could output an array of numbers I just to make sure that it works. Let's double check. We can compile. So far, so good. Yep, good. So now we've read it into an array of numbers, but what's the next thing we need to do? We need to, let's find it again. Where's it gone? There it is, hurrah. We need to find the mean of those numbers. Now, as I said, there's no neat way to do that, so we're going to have to do it ourselves to find the mean of the numbers. Okay, so we can do this all after my file is closed, right? Okay, so here we go. Right, so let's loop through using another counter for, let's say, call it j. J is 0, and then we're going to go through all the elements of array of numbers. But of course, how long is this array of numbers? How many elements are actually in it? Well, we actually know how many elements are in it because it's the value of I, right? Every time there's a new number, I is increased by 1. So we're going to go from j equals 0 up to j equals I plus plus j. Okay, so we're going to add up all the numbers and then divide by the number of numbers, right? That's or the amount of numbers. So let's create a integer called total, and we're going to start by saying that total equals 0, and then we're going to say total equals total plus array of numbers. And again, there are maybe different ways to do it, but here's how I would do it: total equals total plus array of numbers j. Good, and then the mean is going to be, so we can set up a declare a double, right, which we're going to call mean. So we can say mean equals total divided by, of course, the number of numbers, which is I. So let's see out. So we see out mean is, and then the mean, and we end the line. All right, let's have a go at that. I should say I haven't actually tested this, so you know, who knows what could happen. Well, yes, there's definitely something. Can you see what I've done? Yes, it's I've missed the int off here. There we go. That's a nice bit of debugging. I promise at the beginning of part 3 there'll be a whole session on debugging, so you can enjoy that as well. Let's try again. There we are, lovely. All right, let's run it. And it says the mean is 0. Is that right? Well, no, actually, right? Because if you add these numbers up, you should get 1 and then you divide by 4. But you see what's happened here? Yeah, see, I told you this was tricky, right? We have an exercise where we're doing total, which is an integer, divided by another integer, I. So even though we're dividing one by the other, and we said that mean has to be a double, an int divided by an int will always give another int, right? So we have to make sure that one of these things is a double. So the easiest thing to do here, I think, is let total be a double. And then we'll have a double divided by an integer, and that will give us a double. So that's the problem. You see, it's rounded down. So let's compile, run again. There we go. Huh. That's a tricky one, right? And now it's time to move on to the last big chunk of today's session, which is on functions and header files. Of course, writing functions allows us to do more complicated things. You know, programs are made up of functions, and this is how we write them in C++. Now, if you're coming from a language that's more like MATLAB or Python, there's going to be some strange stuff here, which is all new to you, this idea of header files and forward declarations. But that's okay, we're going to build up from the beginning, and we're going to see how this is done in C++. So let's all join in. I'm going to create a new file, learningfunctions.cpp. Head back over to Atom. Okay, let's nick a sort of standard template from something else. Call it learning functions .cpp. All right, and so we're going to have something that looks a bit like that. And I don't think we're going to be needing FStream or CMath, but it doesn't matter. In fact, I know we won't. Let's get rid of them. Okay, so we're going to write a function. You see that when we run the program, everything that's in the main function executes, right? But if we want to write another function, you can write another function just above it. For example, let's create a new function called sign function. It's going to tell you the sign, S-I-G-N, of a number. So in maths, this is indeed sometimes called the sign function. Of course, not S-I-N-E, but S-I-G-N, or sometimes called the signum function to be clearer. Basically, if the number's positive that you put into it, it gives you 1. If it's negative, it gives you -1. And I mean, there's some contention about this, but if it's 0, it normally gives you 0. So it looks a little bit like a step function. So here's the idea. We're going to have a sign function, which is going to take an integer n, right? So it's going to take an integer n, and it's going to output an integer, right? So that's where there's an int at the beginning. Right, yes. So it's going to input an integer n, int n, and it's going to output or return an integer. And because it returns an integer, the type of the whole function is int. All right, so let's write our function. Let's specify the output up front. Here we go. So if n is greater than 0, then the sign of the number is 1. Else, if n equals 0, don't forget the double equal sign, then sign equals 0. And else, of course, no need to check anything else, right? We don't need to do an else if n is negative, because if it's not greater than 0 and it's not 0, it has to be negative, right? Given that n is an integer. So sign is -1. And then we're going to get it to return sign like that. Different ways to write this function, of course. I suppose you could have had return 1, return 0, return -1 here, but this is how we're going to do it. So there's our function, and we're going to try and call it from main. So let's set up an integer n. N is going to be 3, and we're going to get it to put out to the screen sign function of n. N is 3, and that's the end of the line. So we wrote our function up here, main's down here afterwards. Let's compile it and see whether it works. Okay, so CPP learning functions.cpp, sorry, C++ learning functions.cpp. I'm going to output it into something called learning functions. Let's see. Good, that looks good to me. Let's try and run it. Learning functions. 1. Okay, that's right. N is 3, which is a positive number, so we expect it to output 1. Good. All right. Some things to think about here. Order is important. Notice how we've put sign function before main. I'm not going to do it, but you can have a quick go. See what happens if you place sign function after main. I'll pause for a sec just for you to have a go, and then compile, see what happens. Yeah, okay, it's not happy, right? It doesn't like it. Yeah, so order is important, and because order is important, we're going to see what this forward declaration thing is about. And that's just because the compiler reads in from the top, right? When it reads in from the top, if you just have main first, it goes through, yeah, sign function, what's that? Of course, because you haven't declared it yet. But because we declared sign function first, it's happy. Now, obviously, this isn't a particularly good syntax, or rather, it's not very convenient to have all your function definitions at the top. So we're going to see how we can put function definitions in neater places and what this looks like for C++. Don't forget, we have to still deal with global and local variables. So any variables that you define inside a function stay local. That's right. So don't forget how that works. So now I've got a little task for you. Here we go. I want you to add an extra function to this file, absolute value, which returns the absolute value of an integer which is passed to it. Right, so the absolute value is just the value of a number without the minus sign. So that's a horrible way of saying it. So the absolute value of 5 is 5, and the absolute value of minus 5 is 5. Right. So just create another function, absolute value, which returns the absolute value, and then add an extra line to the main function so that it also displays the absolute value of n. Right, so it doesn't just give you the sign, but it also gives you the absolute value. So I'm going to pause, let you have a go at that, and then I'll show you how I did it. All right, so here's how I did it. So we're going to have absolute value. I'm going to pop it in here. Int absolute value of int n. And I'm going to just have it return abs of n, which is the built-in function. Oh, yes, am I cheating? Maybe. But, you know, you could have written something else here that maybe looks at if n is greater than or equal to 0, then it would return n, and if it's less, then it would return minus n. That's all fine. That could work. But okay, that looks good. And then we can also output absolute value of n there. Okay, let's compile, check that all works. Yes, that looks good to me. All right. The problem is, of course, that this is a slightly messy way to do it. Let's instead try to declare sine function absolute value first, but actually write these functions, define the functions later. So if we want to do this, so sine function absolute value, if we want to put these afterwards down here, we can, so long as up front we tell C++ that we're going to do that. The sine and function and absolute value are coming later. So we do that by declaring the function up front. So int sine function int n, and that's it. So really this is just the top line of the function without the brace. So that's it. We've told it that sine function is coming. It's not defined yet, but it's coming. And we can do the same with absolute value as well. So now, when we get down here, it knows that these are coming, so that when you hit sine function, it's like, I know sine function is going to happen, and it'll look down for it. So this is called forward declaration, and in general this is better because it allows for more flexible code. Right? It means that you can move these functions wherever you like. You know, the main doesn't have to be at the beginning, it could be somewhere in the middle, or you can do stuff which is more like what I'm about to show you. All right, so let's compile it and run it. Compile and run it. Nice. Okay, I'm just going to give you a moment to catch up, and then we're going to split our sine function and absolute value functions into separate files. Right, separate files for our functions, and then we're going to call them from the main file. But I'll just give you a sec to catch up. All right, let's go ahead and split the sine function and absolute value into separate files. Right, so we are going to take this out of learning functions here, and we're going to create a new file. A new file which we're going to call sine function.cpp. There we are, and it's still good practice to include our namespace, and I assume it's strictly not necessary, I think, but this way we're not going to accidentally leave out these things. All right, so there's our sine function, all within its own file, and we can do the same with absolute value. So we cut it out, paste it in here, save it, call it absolute value.cpp. That's good. And again, we can pop these things here at the top. All right. And so now we've got this our learning functions file, which says sign function is coming and absolute value is coming. We have the main. But then we haven't actually specified where it can find sign value and absolute value. This is not like MATLAB, where in MATLAB you can create functions in other folders. Sorry, you can create functions in other files, and so long as the name of the file is the same as the name of the function, then you can just automatically call them from any other file, any other script in that same folder. It's not. This is not how C++ works. So we have to do one more thing, and that's how we compile it. So if we go to the compiler, we have to compile all of these scripts together. So we do C++ learning functions, okay. But before that, we can pop in sign function and absolute value.cpp. Right, so we're going to combine these all together, and we're going to output them into, let's just call it sign this time. Does it work? Let's run sign. Nice. Okay. I put sign function and absolute value beforehand. Let's see what happens if I put learning functions at first. It's fine. Why is it fine? Because, of course, a forward declaration meant that the order didn't matter, right? So that's how we write or we put functions in other files in C++. This is quite common. In some languages, maybe more like Python, it's quite common to have different functions in. You can have quite a lot of functions in one script, but yeah, that also happens with C++, I suppose. But it's quite common to have, particularly for quite large programs, to have different functions in different files, and you stitch them all together using the command line. Now there's one little thing we can do that's more than that. So this is fine. We've only got 2 of these forward declarations here. But if you have a lot of files, then a lot of functions to include, this can be pretty tiresome. So we put them in a header file and we include it. All right. So let's take these out of here and put them into a separate header file. Right. So we can save this and we call this learning functions.hpp, H for header. So this is a header file. And now from learning functions.cpp, we can go ahead and we can include it up the top here, learning functions.hpp. Noticing that we're using double quotes here to include this header file, and the header file contains the forward declarations. We have to use double quotes for user-defined header files. All right. If it's a built-in header, if it's a built-in library, we use these angle brackets. But if it's a user-defined header file, we have to use double quotes like that. So this is our. I just tidied that up. Let's have a look. Let's see whether that works. I'm feeling pretty confident. Once again, we have to stitch this all together. But that looks good to me. And it still works. Fabulous. Now, in the 3rd session, we will look at makefiles. So neater ways of dealing with having to type in all of this every time you want to compile. Makefiles is the solution to that problem. But that's coming up all in the 3rd session. Another nice thing about this is that if you have to compile large files, large scripts, C++ compiler has to go through and stitch it all together. But if you only change one of these files, C++, the compiler will go through and realize you've only changed one of these files from the last time. So it doesn't necessarily have to compile all of the stuff from the other files. So say you've only changed learning functions, well, the compiled code it has from sine function and from absolute value it can still use. So that's a nice reason for sort of splitting this up like this. So this can really speed up compilation time. I know the compilation time here has been really short, but for much larger scripts, you can be spending really quite a lot of time compiling. My stuff takes maybe 30 seconds, sometimes a minute, which maybe doesn't sound so long, but is quite can be quite a lot. The header file, as the last thing to say about header files. So here we've just put some forward declarations, but it's a good place to put constants. If you have some constants, maybe something like pi, which you want predefined for all of the files in your project, then here's a good place for it, because you can sort of stick it in there and include this header file everywhere. It's a nice thing to use. And then finally, I have a little task for you. So we've done all of this. Here's what I want you to have a go at. I want you to add a function. Is absolute value less than 1? All right. I've had to write functions a little bit like this before. Is the absolute value of a number less than 1? So it's going to take an integer. I want you to put it in its own file. I want you to add its declaration to the header file. And then I want you to make the main file output is absolute value less than 1 of n. Okay, compile it, check that it works, and let's see. Let's say that it will output 1 if it is true and 0 if it is false. So have a go, and I'll show you how we do it, and then we'll wrap up. All right, so quickly, how am I going to do this? Is absolute value less than 1? So I'm going to start by taking some of this absolute value. Let's see. Is absolute value less than 1.cpp? Okay. Is absolute value less than 1, and then we can put an if abs of n is less than 1, then return 1, else return 0. So it's just return 1 or 0 for true or false. I'm not going to do this, but if you would like to see if you can get it to return either true or false as a Boolean, you can have a look at that data type bool and see how that might change this up here, this int here. Something for you to have a play with if you feel like it. So this is absolute value less than 1. Something else you might want to play with, by the way, is instead of using this built-in function here, see if you can get it to use the absolute value function that you've written yourself. Something else to have a play with. But for now, I'm going to use this. Okay, so far so good. Okay, so I'm going to copy this, and in the headers file, I'm going to make sure that our forward declaration is up here. Int is absolute value less than 1. That's so far so good. Don't forget, if you've ended up changing this to a Boolean because you want to do true or false, then you also need to change the type up here, and that's all okay. Something for you to play with if you want. But then heading back to the main, let's also get to see out is absolute value less than 1 of n. Okay, and then let's compile it all together. Not forgetting our last, let's bring it over, there you go, is absolute value less than 1, all into sine. Will it compile? Oh, that looks good to me. Let's see. Good, and it's output 0 because, of course, the absolute value of 3 is more than 1. I am happy with that. Excellent. Whew. All right, well done. I mean, that's a lot of stuff. And this is the typical format of C++ code. So I think headers, when you first look at C++, is one of the most confusing things. I think one of the most important outcomes of this course is that you should be able to take a look at real life production code. You should be able to take a look at it, code that maybe someone else has written, and you should be able to understand what bits of the code do what. Now that you've seen header files for the first time and you've had a go at creating them, you should be able to understand what header files do. You know, they have all these forward declarations in them, and maybe all these constants as well, and why you have to do forward declarations in C++. Because if you don't declare it up front, then the compiler doesn't know that the function is coming. Higher level languages like MATLAB and Python don't have this problem, but lower level languages like C++, you have to be more clear. Of course, you gain the speed that way through C++, but you lose some of the niceties. So, as I say, I think one of the main goals is that you should be able to look at some C++ code and understand it. And I think with this last part here with header files, you really should be. I think that's a big leap forward in terms of understanding now how that works. Particularly because you'll also see compilation statements like this. And now, again, you should understand why they're written in the way that they are. We're going to have a look at, in part 3, makefiles, which is going to make this look neater. We're also going to take a look at, in part 3, pointers, which is a very C type idea, but we had a very small look at pointers already when we tried to see out a whole array and found that it didn't work. It just gave us a memory address. Well, we're going to try and understand that in part 3. In part 3, we're also going to look at classes, this idea of object-oriented languages, which is a newer idea and something that's in C++ but not in C. We're going to start by doing some debugging, so that'll be something fun. Plenty of time to try and debug some of the intentionally wrong code. It won't compile. You'll be able to have a look and see if you can fix it. And I'm also going to talk a little bit about preparing for what I'm going to call real science. So we're going to look at a package or a library called Armadillo, which I use in my own research for vectors and matrices. So this has some of the linear algebra functionality that we're used to from something like MATLAB or NumPy in Python. So that's all coming up in part 3. I hope you feel that this part 2 has been quite a leap forward. I think it has, and that you're excited about putting the ribbon on the bow in part 3. So that's all for now. Enjoy the rest of whatever is left of your day, and I will see you for part 3.